Now we're going to see what happens when we replace x squared with x plus 5 squared. And this is just going to serve as an example for us for any time you take some equation and you replace all of the x's with x plus something. So first, I'm just going to try to plug in the same x values that I would normally plug in for y equals x squared and see what I get. And as I'm doing that, I notice that it starts at 9 and then it starts to go up. 16, 25, 36, 49. But I know the graph should be a parabola. So it looks like I didn't catch the vertex of this graph. And if you think about it, the smallest y value on this graph should happen at x equals -5. Because every time you square a number, you get back either a positive number or 0. And the only place you'll get 0 here is at x equals -5. So I'm going to put that in the middle of my graph for this particular equation. Picked x values around that and found the y values. So I know when I graph both of these on the same xy plane, for y equals x squared, I'll go out to the right until x equals 2, and then on the left, I'm going to go all the way out to x equals -7. I'm not going to plot the y values that I found in that first table because they're so large that I don't even care to see them on this graph. I'm just going to go up to y equals 4. So first, just sketch the graph of y equals x squared again so we have a reference to see how this changes when we graph x plus 5 squared. And then I'll plot the points for x plus 5 squared. And before you plotted these, you may have guessed from the fact that the vertex is moving from 0 out to -5, that what we did, changing x squared to x plus 5 squared, is just going to push the graph to the left by 5. And that's exactly what happens. So anytime you start with an equation and you replace all of the x's with x plus something, then it will shift the graph to the left by however much you added inside of all of those parentheses.